All right, and now we've got this fancy function, create model. What's happening here when we call model.summary after we've created an instance of our model? We've got layer type, Keras layer, so we go up here. We've got, okay, hub Keras layer, that makes sense. We've got output shape multiple and param number 5,432,713. That's a fairly large number. We come here, total parameters. Then we have down here trainable params and non-trainable params. And it seems that the non-trainable params line up with this param number or parameter. Params is short for parameters. And we have another layer here called dense with param number 120,240. That corresponds to our dense layer here. Well, this is one of the amazing things and the benefits of transfer learning. The reason it says non-trainable params or parameters is because we're using MobileNet v2. And now if we come up here, these are the patterns that MobileNet v2 has learned throughout these layers here. Or by repeatedly going through, if we come back up to the top of this article, by repeatedly going through our images, or the images that MobileNet v2 was originally trained on, better, that's the correct terminology there. So it's gone through all of these images, and if you're wondering, what images did MobileNet v2 go through? Well, it trained on, if we read through here, if we go ImageNet. There we go. So its weights were originally obtained by training on the ILSVRC 2012 CLS dataset for image classification, ImageNet. Okay, let's look up that. ImageNet. ImageNet. ImageNet is an image database organized according to the WordNet hierarchy. Okay. Currently we have an average of over 500 images per node. Okay. So essentially ImageNet is a large database of over 14 million images. And so that these patterns, these parameters, are what MobileNet has learned by training on ImageNet. And so this is the beautiful thing about transfer learning, is that all these patterns that MobileNet has learned through these layers here, and by the way, this is why they call it deep learning, because essentially each one of these layers is a layer in our neural network. So if you imagine this, expand it out, each one of them is a layer, and hence the reason they call it deep is because the diagrams are usually, they have an input layer and then it just keeps going down and down and down and down and down. And so inherently, what each of these layers actually are is a small model within themselves. So these are just multiple pattern finding models layered on top of each other, hence the term deep learning. So if we come back, this is what our base layer is. Those 5.5 million patterns that MobileNet v2 has found within ImageNet. And now we get to utilize those patterns that it's found in our own problem. So rather than try and find them from scratch on our own, which could take hours and lots of compute power that we don't really have, we get to utilize them and train our own 120,000 parameters. So this is our dense layer here. That's what we're going to be training. So we're going to be passing our images to MobileNet. It's going to be using its baseline patterns to figure out what's in our images. And then finally, we're going to stick this layer on top and go, hey, we've got our own data that isn't in ImageNet, but let's use what you figured out in ImageNet for classifying which dog breed is in a certain photo. Now that we have a model, we probably need to make some callbacks. And you might be wondering, what are callbacks? Well, let's save that for the next video where we'll create some callbacks. And then after that, we'll create a function that's going to train our model. That sounds like a good idea to me.